Okay, it's 10.4 and 10.5. This is the last one. Say tier. Okay. Anyway, we're going to add, subtract, and divide. We did multiplying last one, 10.3. This one is add, subtract, divide. And 10.5 has a little added thing we're going to talk about called rationalizing. All right, so adding and subtracting. The way we add, subtract is just like we did with polynomials. We look for like terms. So with like terms, we're looking for square roots that are exactly the same. And if we have two terms where the square roots are exactly the same, we get to take these outside numbers and combine them. So 2 minus 9 is negative 7. But then we're going to put that square root of 6 with it. So it's just like saying 2x minus 9x is negative 7x. But instead of x, we're writing square root of 6. That's all. That's all adding and subtracting is all about. At first, of course, at first. So 9 cube root of 3 plus 7 cube root of 3. Same thing goes for higher roots like cube roots. If it's the exact same, which they are, then you get to add 9 plus 7. And that's 16. And it's still just cube root of 3. Do not add 3 plus 3. Never, 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 never. Stop it. Don't do it. 6 square roots of 14 plus the square root of 13 minus 5 square roots of 14. Okay, so this is here to show you that, hey, if the number underneath isn't exactly the same, you can't add these two together. Not at all. So he is kind of by himself. He's the only square root of 13, so he's going to end up in the answer. But this guy and this guy can combine because they're both square root of 14s. So 6 minus 5 is 1 square root of 14. And you don't have to write the 1, I just did. And then we have the plus square root of 13 that is going to end up in the answer because you had nothing to combine with. So it's kind of like saying 6x plus y minus 5x. You would say 6x minus 5x is 1x, but then you would say plus y in your answer, right? So adding, subtracting, you're looking for square roots that are exactly the same. Same root, same number, same everything. The number on the outside are the only things that actually add or subtract. So then we get to this problem. Negative 6 square roots of 2 minus 9 square roots of 18. And you might be immediately going, wait, I can't add these two. Well, I can't, yeah, two negatives make you add. Same sign add, that's the phrase you need to remember. But I can't because the square root of 2 is square root of 18, the numbers aren't the same. Well, something we did in the last one, 10.3, is we simplified by factoring. 18 is the square root of 9 and the square root of 2, isn't it? And then I want to bring down this 9 in front. This guy doesn't break down, so I'm just going to bring him straight down. Okay? So I had to break down 18 into these two, and then this guy became 3, but it's going to be multiplied by this negative 9 right here. So these two are now going to multiply to give you negative 27 square root of 2, and then you can bring down this negative 6 square root of 2. So yes, so when we have two numbers underneath square roots that aren't the same, we might have to simplify, and then whatever comes out after we take the square root, we're going to multiply by the stuff that's already outside. And then we can say negative 6 and negative 27, they're same sign, so we add and we get negative 33 square roots of 2. I hope that makes sense. And if it doesn't, maybe the next one will. And if that doesn't, ask questions. Send me an email. Square root of 12 and square root of 108, they're not the same, but we can split them up, right? Can't we? So the thing is, whenever I do split them up, a lot of times I can look at this number and figure out what one of the numbers should be. In this case, if I made this 12 times something, it might work out. But both of them actually simplify. So let's simplify both of them. That's going to be square root of 4 and square root of 3, right? 4 is a perfect square. And then this one, I'm going to do this little arrow thing. This one, if they're both going to have a square root of 3 left over, then this one, what's how much does 3 go into this? What goes into it 36 times? Bring down the plus. Yeah, and that's a big perfect square. That worked out really well. But if you didn't want to do it this way, you could just go off to the side and write 2 times 54, 3 times 36. Ooh. All right, so this becomes 2 square roots of 3 plus. This becomes 6 square roots of 3. And now I can add 2 plus 6 and get 8 square roots of 3. Voila. Non. Très bien. 18 cube roots of 2 minus 3 cube roots of 54. So, we didn't do a whole lot of breaking down with cube roots. They were mostly square roots, asking you to find perfect squares. But when it comes to perfect cubes, I want to think of those numbers 1, 8, 27, 64, 125. These are the numbers I'm looking for when I'm trying to break down 54. And if I think about it, well, let's see. How many times does 8 go into 54? It doesn't. So that's not it. What about 27? Oh, yeah. 27 goes in there 2 times. And that works out really well because this guy's a 2. He doesn't break down. He stays the same. Okay? All right, so cube root of 27 is 3, not anything else. And then we say 3 times 3 is 9. And then we bring down the cube root of 2. And we have 18 cube roots of 2 minus 9 cube roots of 2. So they're the same, so I'm going to actually subtract these 2 outside numbers to get 9 cube roots of 2. Okay. Yeah, those were the hard ones on this one, honestly. Those 3, I'm sorry. 4, 5, and 6. So we need to go rewind, look at those again. Need extra problems. You have my math lab to work at, or, I can recommend some more problems that you can find on the internet, or I can just make you another worksheet if you really need more. 18x squared y over 49. So when we're dividing, we use the quotient rule, which says that you can take the square root of the top and you can take the square root of the bottom separately. So first thing, I would write it like this. Square root of 49 on the bottom like that. And then I would, since this is a bunch of stuff being multiplied, I can split those up. Square root of 18, square root of x squared, square root of y over square root of 49. Now, the square root of 18 isn't a perfect square, but he does simplify. Square root of 9, square root of 2. Square root of x squared, I didn't do anything with him. Square root of y, square root of 49. It's a perfect square, so I'm going to leave him alone. And now I want to bring him down. I'm going to write 3 square root of 2 x square root of y, and yes, absolute value of x over 7. Okay, so that's each one of these broken down. So first of all, I broke it down top and bottom, and then I broke this top up into those 3 parts, and then I said 18 breaks down into 9 times 2, x squared, y, same. And then I said each one, square root of 9 is 3, square root of 2 stays the same, square root of x squared becomes this, square root of y stays the same, square root of 49 becomes 7. Okay, that's the idea. Now I want to make this pretty, so let's write that 3x, and then 2y, and then 7. Yeah. Number 8, we have the square root of 6 over x to the 4th. This one's actually nicer than 7. Not sure why it's in this order, but whatever. So we get square root of 6 up here, and then we get the square root of x to the 4th down here. Now remember, when we have a power like this that's bigger than the root number, we can just say, how many times does 2 go into 2 evenly with the remainder of 0? And that's the outside power. So it becomes x squared. And that's just that old trick, but you could have said what times itself gives you x to the 4th, x squared. Now square root of 6 doesn't break down. Only 2 times 3, and neither of those are squares. So that's it. That's the answer. Nice, huh? That's why it was weird that that was second. All right. Number 9 and 10 and 11 ask you to do the thing we did in 10.3 except with dividing. So they start off having split up a fraction like so, but the best thing to do here would just be to divide the two numbers. 40 divided by 2 is 20. And then we can simplify. We get square root of 4 and square root of 5, and that becomes 2 square roots of 5. Okay, that one was quick. Let's try a different one. Square root of 10 is 40x to the third over the square root of 10x. And yeah, you could probably simplify by factoring the top, but then you'll have to divide by square root of 10x. And why don't you just do it right now, because that's really nice. 40 divided by 10 is 4. X cubed divided by x to the first is x squared. And oh my gosh, 4x squared, we just split them up. Square root of 4, square root of x squared, and that becomes 2x. Little absolute value. There you go. So dividing first and then simplifying is way better than simplifying and then dividing. Trust me. All right, so let's look at this big mamma jamma problem. 56x to the fifth, y to the sixth. And that's over the square root of 2y to the fourth. I'm going to go ahead and divide, just like the last two. 56 divided by 2 is 28. And then x to the fifth doesn't divide by anything, so he's going to stay x to the fifth. And then y to the sixth divided by y to the fourth is going to be y squared. Now, I can split this up. 28 is the square root of 4 times the square root of 7. X to the fifth, and then y squared. This guy has a thing where you can divide 2 into 5, right? Square root, so 2. And it goes 2 times, and you're left with 1, a remainder of 1. So let's work this all out. Square root of 4 becomes 2. Square root of 7 stays the same. This has x to the second on the outside and x to the first on the inside. And this guy is just y, right? Those cancel. And then we clean it up by putting the outside stuff together, 2x squared y. And then we put the inside stuff together, 7x. And yes, technically there should be an absolute value around the y. I know. Oh, you might be like, what about the x squared? Oh yeah, you can put it there too, but anything squared is positive, and that's the point of all the absolute value business. It's just to make sure that the letter is positive. So you don't need it on the x squared, although you could put it if you want. Or you can just leave the absolute values off. We'll just assume we have positive letters, okay? Yeah. All right. So number 12 digs into 10.5 for the first time, and it's just saying, hey, here we can multiply things with distributive and FOIL like we did with polynomials. We just have to remember our multiplication rule that says that inside stuff can multiply together and outside stuff can multiply together, but you just can't cross between inside and outside stuff. So here, everything's inside. We're all good. Square root of 35, square root of 15, and they don't break down. 5 times 7, 5 times 3, they don't break down. They're not the same, so we can't subtract them. That's the answer. It's weird, but true. Number 13 is a FOIL problem. We have 3 plus the square root of 3. And then we have 4 plus 4 square roots of 3. So now we have inside and outside stuff, so we got to be careful about that. These two are both outside, so we can multiply them, get 12. That's first. Outside, we got 3 times 4 square roots of 3, so 3 times 4 can multiply, but then we still have that square root of 3. Inside, we have 4 times square root of 3. They don't multiply. So we put the outside number and then the inside number. And then here, we have the square root of 3 times this, and the 4 is outside. He's the only one. And then square root of 3 times square root of 3 is square root of 9. All right, that's foiling. And then there's a little thing that's happening over here. This guy is 3. So really, it's 4 times 3. So we get 12 plus... Let me just do one thing at a time. Plus 12. So since square root of 9 is 3, we say 4 times 3 is 12. All right. And now we have some like terms. So this guy and this guy can combine to give you 24. And then this guy and this guy can also combine because they both have a square root of 3. That's 16 square roots of 3. One thing you cannot do is you cannot add these two things together because, like terms, this guy has a square root of 3. That means he has to before you can add. So that's why we leave it like this. 14 is another one. 5 minus square root of x. And then 6 minus square root of x. But here we have numbers and letters. I guess that's why it's here. Another full problem, though. 5 times 6 is 30. 5 times negative square root of x is going to be negative 5 square root of x. Right? The negatives. And this guy becomes negative 6 square roots of x. And yes, I want to put the outside number first and then the inside number. It just makes it cleaner and nicer. And then last, I have negative times a negative is a positive, and then square root of x squared. Well, the square root of x squared is just x. Also, these two combine. So I get 30, same sign add, I get negative 11 square root of x, and then he becomes plus x. And none of these are like terms, and so you're all done. And yes, you could put absolute value around the x, but we're just going to assume. Actually, they say that. Assume all variables represent positive real numbers. So you don't need this absolute value anymore if they tell you to assume that. Now, 15 uses this idea of foiling, but specifically for two situations. One is where you have a square root in the denominator of a fraction. This is called rationalizing. And rationalizing means that if you start off with this, a single thing in the denominator with a square root, we can multiply the top and bottom by that thing. And what this is anything divided by itself is 1. So this is really just 1. I'm not going to cancel them because then we'll just be right back where we started. But instead what I'm going to do is I'm going to multiply straight across. And what this does is it creates 8 square roots of 5x in the top, and then the square root of 25x squared in the bottom, right? Because inside stuff can multiply. And now this guy you can take the square root of it. Square root of 25 is 5, and the square root of x squared is x. And no, you cannot cancel these because one's inside and one's outside. So these two actually go with him, but they don't have anything in common, so we're done. The point of the name of the game is to get the square root out of the denominator, and that's what we did. It doesn't look prettier, it's not simpler, but it is rational. I won't go into what that means. Just, do the thing. When you have this and it's a single thing with a square root in the bottom, we're going to multiply the top and bottom by that thing. Yeah. So this gives me, I'm going to go straight across now. 11 square roots of 7x. I'm sorry, 11x square roots of 7x. And then down here, the square root of 49x squared, which, I don't know if you know this, is 7x. It works out every time like that. And the whole point of this is that this times itself becomes 7x without the square root. Same thing here. This times itself became 5x without the square root in the denominator. So it works out every time. You don't have to go through this step right here if you don't want to. Now, okay, so we want to simplify this with outside stuff. And these two cancel, but these don't. So we have 11 square root of 7x over 7. And that's it. Do not cancel those 7s. Bad, bad, bad. Okay. So when we rationalize with one term, we just multiply top and bottom by itself. But when we rationalize with two terms in the denominator, we have to put a parentheses around it, first of all. That's just good habit to have. And then we're going to multiply the top and bottom by that thing, only change the sign. See how it was minus and now it's plus? And I'm going to do the same thing on top, 7 plus square root of 5. So these two always have to be exactly the same because it's 1 when we cancel them. But these two have to have opposite signs. So opposite, same. Okay? Now we're going to distribute and FOIL. Oh, yeah, that's why we did all that stuff. So we got 5 times 7 is 35, plus 5 times square root of 5. We'll just leave it like that. Here I want to FOIL, and I'm going to FOIL below and then put the answer right here. So let's see, 7 times 7 is 49, positive 7 square root of 5, negative 7 square root of 5, and then negative square root of 25. And then, oh look, these middle two terms cancel. So I'm really left with 49 minus the square root of 25 is 5. No, don't. No. So instead, you need to do this. Leave 35 plus 5 square roots of 5 alone. And then 49 minus 5 is 44. And now there's nothing in common with the outside numbers, so this is done. Okay? So don't make that mistake of getting to this point and going, oh, look, 5's canceled. No, don't do that. Number 18, the last problem in the last worksheet. Aren't you guys excited? I hope you guys want to do summer classes, by the way. It's online, of course, all online. So you might not, but, you know, I feel like during this time of coronavirus, we have to be very careful, and we want to keep our students learning and here and doing problems. And so if you're like, hey, I want to do online, but I don't want it to be too hard. You know, most instructors know that, and they're trying to make it completely doable, you know? Now, if you got an instructor that's like making it hard, just like regular classroom was, without being available for you, then definitely drop that class. Okay, so when I multiply both top and bottom by square root of 10 minus 3, right, different signs and then same sign, I will get 4 square roots of 10 minus 4 times 3. And then down here, I'm going to FOIL, so I'm going to do that below. Let's see, square root of 10 times square root of 10 is square root of 100. And then outside is minus square root of 3 square roots of 10, sorry. Inside is positive 3 square roots of 10, which is going to cancel, and then negative 9. So we end up getting 10 minus 9, right? Square root of 100 is 10 minus 9. And that is going to give me 4 square roots of 10 minus 12 up top. And 1 down here, which I don't need to write. I can just do this. All right. Thanks for coming.